Okay, so in the nucleus, inside the nucleus we have protons, which are positively charged, and neutrons, which are neutral charged. Okay, but how do we know how many? Well, the number of protons is equal to the atomic number, and the number of neutrons is the atomic mass minus the atomic number rounded. So hopefully you've obtained yourself a copy of this. If not, you can either come and see me, or I'm actually going to post the link up on Classroom. But this is the science data booklet that you will be using for all of your assignments and your tests. So it's very important that you obtain one. Now, this is a copy of the periodic table as it is seen in there, and if you look, so this is on page 6, right here is the key, and the key is shown there in the slide. So there it shows you where the atomic number is, okay, and that's the number of protons in an atom or an ion, okay, and that's kind of what determines what the element actually is the number of protons inside of its nucleus. The number of neutrons, okay, is going to be the atomic mass, again that's given to you there in the key so you know exactly where to find that, minus the atomic number. And the reason for that is because neutrons and protons have pretty much the same amount of mass. So they have a mass number of 1. And if you, like, the atomic mass of a particular element is its protons and its neutrons combined. So if we know what the total mass is, or the total number of protons and neutrons, and then we take away the number of protons, we would be left with the number of neutrons. And that's essentially what you're doing there in that calculation. As you will notice, though, most of the atomic masses are not like a perfectly round whole number. And the reason for that is because of what are called isotopes. And an isotope is different than an ion. An isotope is just where the number of neutrons varies within a particular element. So you would have seen this in the simulation where they had like an unstable nucleus, and that unstable nucleus meant that it just didn't have the right number of protons to neutron kind of ratio going on there. If though you were to have added some neutrons or taken some away, you would have messed around obviously with the mass of that particular nucleus, but you also would have made it stable. And there's actually generally more than one configuration of protons and neutrons inside a nucleus that would work to have a stable nucleus. In addition, a lot of people think that for some reason the electrons carry enough weight to be counted there. They don't carry enough weight. They're actually super, like they have a super small mass, so we just kind of pretend that they don't exist when we're trying to calculate the number of neutrons in there. Alright, so again, the number of protons is the atomic number, where the number of neutrons is the atomic mass minus the atomic number.